Why nothing persists without paying a price. By now, two things should be clear. Entropy records the cost of change, and gradients give motion direction. But there is a deeper consequence that follows from both. Nothing that lasts does so for free. Persistence always requires payment. Any system that remains organized must continuously get rid of something. Energy, heat, waste, disorder. Something must be exported to the surroundings. This loss is not a flaw or inefficiency. It is the condition that allows stability to exist at all. Consider a star. A star does not persist by holding itself together. It persists by burning fuel and radiating energy outward. That radiation is not accidental. It is the price the star pays to resist gravitational collapse. When the fuel runs out, the star cannot negotiate with physics. The accounting has already been done. The same principle applies to living systems. Cells remain organized by exporting entropy. Metabolism works by taking in low entropy resources and releasing higher entropy waste. If a living system tried to keep everything inside, to conserve perfectly, it would quickly poison itself and fail. Life survives not by minimizing loss, but by managing it. Machines follow the same rule. Engines, computers, power grids, all stable systems operate by dumping excess energy into the environment. Cooling systems exist because without dissipation, structure breaks down. Stability is not about conservation. It is about controlled loss. This is where intuition often fails us. We tend to think persistence means resistance to change. In reality, persistence means regulated change. Too much change too quickly destroys structure. Too little change makes systems brittle and fragile. Stability lives in between. Systems that last are not rigid. They are adaptive. They absorb fluctuations, shed excess energy, and respond without breaking. The price they pay is continuous dissipation. This is why nothing persists in isolation. A perfectly closed system, one that neither gains nor loses energy, cannot sustain complex structure indefinitely. Without dissipation, gradients flatten. Without gradients, motion stops. Without motion, structure decays into equilibrium. Persistence requires openness. It requires interaction with an environment that can absorb loss. This also explains why collapse is not failure. Collapse is often part of persistence at a larger scale. Stars explode and seed galaxies with heavier elements. Ecosystems collapse and reorganize. Civilizations rise, fall, and leave behind infrastructure, knowledge, and altered environments. Individual structures fail, but persistence continues through transformation. What survives is not what resists change, but what can pass structure forward through it. There is no guarantee in this process. Most patterns fail. Most arrangements cannot handle noise, fluctuation, or disruption. A small number persist, not because they are perfect, but because they fit their environment well enough to keep paying the cost. This is selection without intention. No system chooses to survive. No structure plans ahead. Those that persist do so because they can manage dissipation more effectively than alternatives. They leak energy at the right rate. They respond without shattering. They remain coherent long enough to matter. This is true at every scale. Atoms persist because certain configurations minimize instability. Molecules persist because bonds distribute energy without breaking. Life persists because metabolism balances intake and loss. Galaxies persist because gravity constrains motion over immense distances while allowing energy to radiate away. The universe does not preserve structure by protecting it. It preserves structure by allowing it to fail selectively. Persistence is not permanence. Nothing lasts forever. But persistence determines what lasts long enough to shape what comes next. Every stable pattern carries forward the record of what it cost to maintain it. And this brings us to the final step. If entropy records cost, gradients give direction, and dissipation pays the price, then there must be a way these processes remain coherent across scales, a way the universe keeps track, not intentionally, not consciously, but consistently. To understand that, we need to talk about how the universe keeps score. My name is Charles Carroll. Thanks for taking the time to listen.